Hello friends, welcome to this next session on Laplace transform. This video will introduce to one more theorem called as initial and final value theorem. Come on, let's see what is the statement of initial and final value theorem and how to apply it to problems in Laplace transform. Initial and final value theorem. The first initial value theorem says that if we can define Laplace of f of t as a function of s, then as t tends to 0, the function of f of t is the same as limit s tending to infinity s time Laplace of f of t or your f of s. Final value theorem is the same, but instead of this t moving to 0, this is replaced as t moving to infinity. If t moves to infinity, this infinity over here in initial value theorem flips to s moving to 0. So keep in mind, if it is initial value, t moves towards 0, and if it is final value, t moves towards infinity. That is going to be your left hand side fixed. And what is going to be your right hand side? Limit s tending to infinity, the opposite of it, you will have to multiply by s, the Laplace of the function. Multiply by s, the Laplace of the function, and allow limit s tending to 0. Now, come on, let us apply this initial and final value theorem to a problem and see how does this work. Okay, right. First problem, let me verify initial and your final value theorem for the function f of t equals a e power minus bt. So, this is my function f of t. I'll have to verify initial value theorem and the final value theorem for this function f of t. What does my initial value theorem say? If Laplace of f of t is denoted by f of s, then t tending to 0 f of t is limit s tending to infinity s into f of s. Let us begin with the left hand side. What is there on the left hand side? LHS is limit t tending to 0, the function f of t. This is nothing but limit t tending to 0 of, what is my function f of t? A e power minus bt. Which tends to 0? T tends to 0. Where is our t? In the power of e. What we know about e to the power of 0? E power 0 is always equal to 1. So as t tends to 0, this value will approach a into e to the power of 0. So it moves towards a. So this is my left hand side. Now, come on, let us verify our right hand side. What is there on the right hand side? It is limit s tending to infinity s into f of s. What is our f of s? It is nothing but our Laplace of our function s. What is the Laplace of the given function is a e power minus bt. So, this is limit s tending to infinity s times of a is a constant. So, a comes outside, leaving you with Laplace of e power minus bt. Now, I know that Laplace of e power minus bt is 1 divided by s plus b. Now, because there is minus sign, this will become plus. Now, as we allow s to infinity, you will have infinity by infinity, which is an indeterminate form. So, what you do is take your s common outside, both from your numerator and denominator. So, what will happen over here? Your denominator gets converted as s into 1 plus b by s. Now, as I allow limit s tend to infinity, what will happen? We will have 1 by infinity, which moves towards your 0. There is no s over here in the numerator, so you will have a divided by 1 plus 0. So, where does it move towards? It moves towards a. So, this is my right hand side. So, I have verified that LHS and RHS are the same. And what we have verified this for? I have verified this for my initial value theorem. Now, I'll have to verify the same for my final value theorem. What does our final value theorem say? If Laplace of f of t is f of s, then t tending to infinity, final means t tends to infinity. F of t is limit s tending to 0, s into f of s. So now let us verify for our LHS. What is our LHS? Limit t tending to infinity of my f of t. What is my f of t? It is a e power minus bt. So it is a e power minus bt. As t tends to infinity, we have e power minus infinity. But as e power minus infinity it moves towards 0. So this quantity as t tends to infinity moves towards 0. So a into 0, so this makes it as 0. So my left hand side is obtained as 0. Now let me move to my right hand side. What happens in my right hand side? Limit s tending to 0, s into f of s. What is my f of s? It is nothing but Laplace of a e power minus bt. So now as we move, limit s tending to 0, s into a comes outside. What is the Laplace of e power minus bt? We know that that is 1 divided by s plus b. So totally we have limit s tending to 0 of SA by S plus B. Now as S tends to 0, what will happen? My numerator and denominator approaches 0 and hence the total value will move towards 0. Hence we see that both the left hand side and right hand side approaches 0. Hence we have verified the final value theorem for the function a e power minus bt. Hence, both initial and final value theorem have been verified for the function f of t is a e power minus bt. Thank you.